Welcome! We're going to be talking about segment lengths in a circle, and our objectives for this lesson are to understand the relationship between segments and their lengths within a circle. So we have a few rules, so we're going to write those down first. So I have three different ways that segments could be represented in a circle. The first one is when the intersection is inside the circle. And we do what we call pop, pop, and those are set equal. So it's part times part equals part times part. So my parts are A, B, X, X, and Y. When the intersection is outside the circle, I use ow, ow, which is outside times whole equals outside times whole. Okay, so outside, or B, times whole, A plus B, is equal to outside, or Y, times whole, X plus Y. We set those equal. Again, the intersection here is outside of the circle. So I'm going to do ow, ow, and we're going to have outside times whole, which happens to be the same as outside in this instance, equals outside times whole. As we go through these video notes, you will probably find it helpful to refer back to these equations. So we're going to start with just a few examples. The first thing I want to do for each example is determine, is my intersection inside or outside? In the first example, it's inside. So I'm going to use pop, pop. So I'm going to identify my two parts along one line, 3 times X, and my two parts along the other line, 9 and 5, 9 times 5, and I'll set them equal. 3x is equal to 45, x is equal to 15. And the second one, my intersection is outside of the circle. So I'm going to use ow, ow. So I have outside times whole equals outside times whole. Four times 16 is 64, is equal to x squared, and I have that squared there, so I'm going to take the square root of both sides, and I'll get that 8 is equal to x. Let's look at some more. Here I identify that my intersection is outside of the circle. So again, I'm going to use ow, ow. I have an outside of 3 and a whole that's given to me, which is x. And an outside that's 5 and a whole that is 10 plus 5, or 15. So I would get 3x is equal to 75. Then I'll divide by 3 on both sides and get x is equal to 25. Again, I identify that my intersection is outside of the circle. So I'm going to use ow, ow. I have an outside of 3 and a whole of x. And then I have an outside of 4 and a whole of 12. So I get 3x is equal to 48, or x is equal to 16. Let's look at some more. I identify in this first one that the intersection is inside the circle. That means I'm going to use pop, pop. So I'm going to look along this line first. My two parts are 3 and 7, and then I'll look along the other line, and I have x and 5. I'm going to set those equal to each other, and I'll get 21 is equal to 5x. X is equal to 21 over 5. And I could turn that into a mixed number if I wanted to, which would be 4 and 1/5. On the next one, identify that the intersection is outside the circle. So I'm going to use ow, ow. So outside times whole equals outside times whole. Then you get z squared is equal to 192. Take the square root of both sides, and z is equal to 13.9. And that's a rounded answer, but we'll use that. So they don't always work out beautifully. Here we identify that we have an intersection outside of the circle. So we use ow, ow. And we'll use 8 plus y. So what we're going to do is 15 times 15 equals 8 times 8 plus y. 225 is equal to 64 plus 8y. And we'll divide by 8 on both sides. And say that y is equal to 161 over 8. And we can write that as a mixed number if we want to. 20 and 1/8. The second intersection is also outside, so we'll use ow, ow. Outside times whole, outside times whole. So we have 6 times 14 and 7 times 7 plus y. That gives us 84 is equal to 49 plus 7y. If I subtract 49 from both sides, I get 35 is equal to 7y, so y is equal to 5. Let's look at a few more examples. I have an intersection outside of my circle, so I'm going to use ow, ow, outside times whole, outside times whole. So 14 times 34 is equal to 16 times x plus 16. We get 476 is equal to 16x plus 256. We subtract 256 from both sides and we get 220 is equal to 16x. And if we divide it out, we get x is equal to 13.75. For this next one, our intersection is inside of the circle. So we're going to use pop, pop. I'm going to go along each line. And I have 3 times 7, 6.5 times m. That tells me 21 is equal to 6.5m. We'll divide both sides by 6.5, and m is equal to 3.2. Let's look at 2 more examples. Here my intersection is outside of the circle. So I'm going to use ow, ow. I have outside times whole and outside outside times whole. So x times 6 equals 3 times 7. I get 6x is equal to 21. I divide both sides by 6, and I get x is equal to 3.5. The next one, my intersection of 3 lines is outside the circle, so I know I'm going to have to use ow, ow. I'm going to start by picking 2 of the lines to work with. So I will work with outside, which is 5, times whole, which is x plus 5, is equal to 7 times the whole, which is 22. So I get 5x plus 25 is equal to 154. I then subtract 25 from both sides, and I get 129. I divide both sides by 5, and x is equal to 25 and 4/9. I'm not done yet because I now have to find y. So let's take a closer look at y. So again, I have outside intersection. So I'm going to use outside times whole equals outside times whole, or y times y is equal to 7 times 22. That gives me y squared is equal to 154. I take the square root of both sides, and y is equal to 12.4. Alright, that's it for today's lesson. If you have any questions on any of this material, make sure you ask me at the beginning of next class. We'll spend a little bit of time reviewing this and doing an activity next class. Thanks!